Okay, welcome to another video. Today I will be looking at index laws. In my part 1 video, I will look at the 3 basic index laws and then a quick introduction to fractional indices, and then in part 2 I will go into fractional indices and negative indices in more detail. So let's get started on our first example. Now we have in front of us P times P times P times P. Now if we're multiplying all these P's together, we get then P to the power of 4. This number 4 is what we call an index. Now there are other words you can use for this. You can call it a power, you can call it an exponent as well. So there are lots of different names for the same thing. In this video I will refer to the 4 as an index. So that's a very important thing to remember. The small number above the letter, or in some cases above the big number, the integer, is called an index. Now, when we have whole numbers and letters, we treat them separately. Let's look at the second example. So here we have k times k times k. That will be k cubed, or k to the power of 3. Now the number is treated separately, so we put the 6 in front of the k. Remember, in algebra we don't need to write the multiplication symbol, we just put it together and we get 6k cubed. So have a go at the 6 questions below and see if you can find the answers. Please pause the video and have about 4 or 5 minutes. See if you can answer questions A to F. Okay, so you should have got the answers A cubed, or A to the power of 3, B to the power of 5, C to the power of 4, part D, 4D cubed. Remember, the D and the 4 are separate here. The next one is 7E squared, or 7E to the power of 2. And lastly, 9F to the power of 4. Notice, in case you're a little bit confused by that remember P plus P plus P plus P plus P equals 4P. So that's a crucial difference between what we did in our example. P times P times P times P is P to the power of 4, whereas P plus P plus P plus P is 4P. So notice where the 4 goes when you're adding or you're multiplying letters together. Let's look at our second example. So for this question here, we're going to use what are known as index laws. So x squared times x cubed, well, that's the same as saying x times x, that's what x squared means, multiplied by x times x times x. How many x's do we have? We have x to the power of 5. So look at the question. look at the answer, is there a quick way we could do the same calculation? Take 10 seconds, see if you can think of the answer. Okay, hopefully you've noticed that we could actually add the indices. We could add the 2 and the 3, and that gives us 5. Now, division works in the same way, but instead of adding the indices, we minus the indices. We minus the little numbers, sorry. So, we get for our second example, 7 minus 3 is 4. Notice this only works if you have the same base letter. Then you can just minus the little letters when you're dividing. Now our next question is x to the power of 4 divided by x cubed, or that will be x to the power of 1. This can also be written as x on its own. Really remember this important fact, that x to the power of 1 is the same as x itself. That is very important. Now, my last example highlights a different question. X to the power of 5 divided by x to the power of 5. That means we minus the small numbers and we get x to the power of 0. Now, an important fact to remember is that anything to the power of 0 is the same as 1. So x to the power of 0 is the same as 1. Likewise, 8 to the power of 0 is also 1. My favourite football team in the world, Derby County, if you make that to the power of 0, that's also 1. So if you want something to write down as a note, this is my very important fact, that if you take Derby County, my favourite football team, to the power of 0, you will get 1. Please remember that. It's an important fact to remember. So, using what we've just done, see if you can complete questions A, D, G and J and see if you can get the right answers. Take about 2 or 3 minutes on this exercise. Okay, hopefully you got the answers I will give you. So we have x to the power of 8, y to the power of 5, y to the power of 29, and finally this is y to the power of 1, which is the same as y. Notice the letter does not matter, x, y, d and so on, as long as you use the power laws correctly. Now, in my third slide, we're going to combine some of the features we've seen in the first 2 slides. Now, when we have whole numbers, integers, before the x's, we treat the numbers and the x's separately. So, in my first example, well, 5 times 4, well, that is 20. And then using what I did in the previous slide, x squared times x cubed is x to the power of 5. You treat the numbers separately, you treat the letters separately. Now, in my second example, we do exactly the same thing. So 2 times 7 is 14. X to the power of 5 times x squared is x to the power of 7. And we're done. So, just like in the previous slide, have a go at the questions below. See if you can work out what they are in the same way. Okay, hopefully you've got the answers. 5 times 3 is 15. x squared times x cubed is x to the power of 5. Likewise, 4 times 2 is 8. Y squared times y to the power of 4 is y to the power of 6. Now, in the last example, you treat it exactly the same way. Notice if there is not a number before the x to the power of 4, we treat it as if there is a 1 in front. That means 2 times 3 times 1 is 6. X squared times x cubed times x to the power of 4 is going to be x to the power of 9. And we're done. Excellent. So let's look at my next slide. We'll look at slide 4. Now here we have exactly the same idea. This time we are dividing, so we treat it in the same way. For my first example, 10 divided by 2 is 5. X to the power of 5 divided by x to the power of 3 is x squared. The biggest mistake my students make is not the operations, but noticing we have a divide here, not a multiplication sign. So we have to do kind of the opposite of what we did in the last slide. Most of the times those silly mistakes can cost you marks, so make sure you really read the question carefully. Likewise, in my next question, 45 divided by 9, that will be 5. X to the power of 9 divided by x to the power of 5 is x to the power of 4. Now, likewise, have a go at questions C, F and I. See if you can do those in exactly the same way. Okay, well, I hope you all remembered that x on its own means the same as x to the power of 1. That's going to be very helpful in this question. So, 48 divided by 16, that will be 3. X to the power of 4 divided by x to the power of 1 is x to the power of 3. Likewise, 4 divided by 2 is 2. Y squared divided by y to the power of 1 is y to the power of 1. And of course, we can rewrite this as 2y, y by itself. The next question, don't let this line confuse you. It still means divided, so we still treat it in the same way. 5 divided by 5, well, that will be 1. X squared divided by x squared is x to the power of 0. Remember from the previous slide, x to the power of 0 is 1. And my favourite question to all my students, 1 times 1 is definitely 1, not 2. Please remember that. Now, an alternative way of doing the same thing is by cancelling or simplifying. So the 5 simplifies with 5, the x squared simplifies with x squared, and you get the answer directly here as 1. That is an alternative that you can use. Now, my penultimate slide refers to my third index law, which is when brackets exist. And we have to be slightly careful when we do these questions. Now, if we have brackets, it means that we multiply the 2 and the 5 together. So when we have brackets, I'll repeat that again, we multiply the two little numbers. So in this case, we get x to the power of 10. This is because what this question means is we're multiplying x squared by x squared by x squared by x squared by x squared. So we're multiplying x squared 5 times. That's the same as doing 2 times 5. When we have whole numbers, we have to be a little bit more careful. So we separate out the 2 and the x cubed. So we do 2 to the 4, or 2 to the power of 4 separately, and then we do the x cubed to the power of 4 separately. Now, 2 times 2 times 2 times 2 is 16. And x cubed to the power of 4, like our first example, will be x to the power of 12. The biggest mistake that's made in these kind of questions is you forget to multiply the 2 also to the power of 4 as well. So make sure you do both steps of this calculation. That's very important. Okay, so these are a little trickier. Have a go at the questions below. Again, treat the numbers separately to the powers that you see. Okay, so this is 5 times 4. That's equal to 20. Very big 0. X squared times x cubed. Well, that would be x to the power of 5. And then y cubed times y to the power of 5 is y to the power of 8. Likewise, 12 times 3 is 36. P times p squared. Well, remember p on its own means p to the power of 1. So 1 plus 2 is 3. Q squared times q squared is q to the 4. And finally, well, nothing or 1 times r is just r. The r stays the same. Okay, and we approach this in the same way. So 12 divided by 4, that's equal to 3. X cubed divided by x to the 1, that's x squared. And careful on this part. Y to the power of 1 divided by y to the power of 2 is y to the minus 1. Remember, we are doing 1 minus 2. We are not doing 2 minus 1. Remember which order you are doing the operation. If you're not quite sure about that, then please look at my video on negative numbers. That will help you see what's going on with this kind of question. Now, my final part of this video is to show you where fractional powers come from. And these are my examples that you see in front of you. Now, if you work through this nice and carefully, 2 to the power of 5 is 2 times 2 times 2 times 2 times 2. And if you work that out, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. So this means that 32 to the power of 1/5 is 2. So if we have a fractional power, it's working backwards from the power. Another way we can write this is the quintic root of 32, which if you check on your calculator is the same as 2. These words quartic, which is for 4, quintic, which is for 5, come from the French and the Spanish. So in French we say quatre for 4 and cinq for 5. I think in Spanish cuatro is 4, cinco is 5. So that's where these words come from in mathematics. I've often found teaching international students, whether they're French speaking or German speaking or Italian or Spanish speaking, that often a lot of mathematical words have the same roots. So for example, a surd, which is a square root number, has its origins in Latin with surdos, or cerdos in Spanish, okay, whereas some languages might use a different origin. So for example, in German, a root is known as a Wurzel, which is a direct translation of root, as in like a root in your garden, for example. So if you ever get confused by some of these specialist words in mathematics, notice they often have a Latin basis. So the more languages you learn, the more mathematical vocabulary becomes easier. So that's a very good reason to learn French or German or Italian or Spanish at GCSE or iGCSE. Okay, enough about advertising languages as well. Let's carry on. So 5 cubed is the same as 5 times 5 times 5. That will be 125. So I'll give you 5 seconds. See if you can work out then what 125 to the power of 1/3 is. Okay, hopefully you're seeing the pattern. Well, it's the cube root of 125, which is 5. Likewise, 12 squared. This is one that all my students should know off by heart. That is 144. And so 144 to the power of a half, well, that will be 12. Likewise, 2 to the power of 8. Well, if you multiply by 2 enough, you should get 256. Notice that is why often if you have graphics cards or hard drives, that things often work in 128s or 64s or 256. Or even 512, everything works in computers in terms of 2's, in terms of powers of 2. So 256 to the power of 1/8, well, that will be 2. And last question, I'll give you 15 seconds to have a go at that. See if you can work out my last 2 examples. Okay, so you should have worked out that 3 to the power of 4 is 81, and there likewise 81 to the power of a quarter is 3. Okay, so I've designed my examples to show the link between ordinary powers, so 2 to the power of 3 for example, and then see what the relationship is with the fractional power as well. If you can build up these relationships in your mind, you will find mathematics much more easy to accomplish, much more easy to do. So I really encourage you to look through this particular slide and make sure you understand the idea between normal powers and fractional powers as well. So this is the end to my part 1 video on manipulating indices. In my second video, we will do a recap on what we have looked at in part 1, and then we move on to more complicated fractional powers, and we'll start looking at negative indices as well. This is a topic that's often overlooked by students, and it's an important topic to understand when we get to higher levels of mathematics. So you really need to understand the key ideas and concepts behind indices. Thank you for all the people that have watched my videos and subscribed so far. As I've said to some of my students, when or if I get to 100 subscribers, I will be doing a bonus video at 100 subscribers where I will explain one of these mathematical topics in German. So I'll actually do one of my videos in German. I don't know how that will go, but once I achieve 100 subscribers, I will certainly try. Okay, thank you for watching. Please subscribe if you haven't already, and thank you for watching this video. It's been a pleasure. Thank you.